This one I didn't find too bad. Okay, so the first one, I organized my notebook really well today too, I think. So I'm going to go back and forth. So you have your continuous function f that's defined on the closed interval -6 to 5. The figure above shows a portion of the graph f consisting of two line segments in a quarter circle centered at the point 5, 3. It's known, this stumped me for a while because I was working out a problem like, how the heck am I going to find that? Well, they gave it to you, you big fat bonehead. This is going to be an important piece of information at one point or another. Everything will be. And if the integral from -6 to 5 of f of x dx equals 7, find the value of the integral of -6 to -2 of f of x dx and show the work that leads to your answer. Find this one pretty easy? I came back and I said, well, the integral from -6 to -2 of f of x dx, that equals my integral from -6 to 5 of f of x dx minus my integral from -2 to 5 of f of x dx. Now this isn't what the grading rubric shows, but I can't understand why anything would be wrong with it. And I hence came through and I said, well, okay, I know the integral from -6 to 5, I know this is 7, minus what's my integral from -2 to 5. And we come up here and we accumulate our areas, and those cancel each other out. It's working, Lynn.
Figured out.
I did. It dropped over. I just had to bring it up, but thank you.
Yep, nope, not a problem.
So then we have this little niblet right here. Well, that's going to cancel out this little niblet right there. So we get to 1, and we're still at 0. And then I have this cute little trapezoid here, which there's lots of ways you can do it. I would say 1 plus 3 is 4 divided by 2 is 2 times 1. So the whole area, that's 2. And then to get this guy underneath here, we really need to picture a square of area 9 minus this quarter circle, right? And the quarter circle of radius 3, so the whole circle, what would that be? 9 pi. We divide that by 4, so we get 9 pi over 4 should be my area right in there. If I add those two together, I get what? 11 minus 9 pi over 4. So I come down and I say minus 11 minus 9 pi over 4. I distribute that little guy. And what do I say? I have -4 plus 9 pi over 4. That is what my integral from -6 to -2 of f of x dx equals. Right? That is work. I should have my grading rubric here so I can tell you what they're all worth. 2 points. Integral and answer. Wait, wrong one. To the right row. 3 points. Ooh. 3 points for your original integral. You're going to get a point for finding the value of that integral and a point for your answer. Then that same function, they want you to evaluate what the heck is the integral from 3 to 5 of 2 times f prime of x plus 4. So if I integrate that, I know the antiderivative of 2 f prime of x, that's 2 times f of x, right? Plus 4x, and we're going to evaluate that from 3 to 5. So we're going to get top limit minus my bottom limit. And my top limit is going to be 2 times f of 5 plus 20 minus 3 times f of 3 plus 12, I hope. Where did I screw up? 2. Thank you. Yep. You can't make stupid things like that. Yeah, that's a 2. Thank you. And there's a 2. So then I need to know what the heck is f of 5. So I come over here and say, oh, f of 5 is 0. So this is going to give me 0 plus 20 minus, this is 2 times, what the heck is f of 3? It's 3 minus the square root of 5 plus 12. So then I keep chugging and plugging here. This is going to give me 20 minus, well, I'm going to say 6 minus 2 root 5 plus 12, which is going to give me 20 minus 6 plus 2 root 5 minus 12, which should give me, what does that give me? 2 plus 2 square roots of 5. Should be my integral from 3 to 5 of 2f prime of x plus 4 dx. Yep. 2 more points. Fundamental theorem of calculus. Put your answer. Okay? Then we roll on to part C. Part C says the function g is given by the integral of negative 2 to x of f of t dt, a function defined as an integral. Find the absolute minimum of g on the interval from negative 2 to 5. Justify your answer. Well, Kruger comes down and he thinks, well, minimums and maximums happen at critical points or values. They happen at critical points. And I know my critical points, my function defined as an integral, I know g prime of x is going to actually equal f of x by the first fundamental theorem. So I come up and I look and I say graph of f, that actually equals g prime. Therefore, I have critical values or points at x equals negative 1. And I'm going to have one right there. We know what that point is because we can find it from the slope. That's going to be x equals a half. X equals 1/2. And I also have, well, that's an endpoint. I got x equals 5. And remember, absolute and extreme values also happen at this endpoint, could happen at the endpoints of x equals, what is that, negative 2? No. Yeah, negative 2. Well, then I'm going to kind of look back here, and I'm going to say, well, here at negative 1, I went from positive to negative. That would be increasing and then decreasing. So that is a potential maximum. And that's a max because I went from positive to negative. A half, I went negative to positive. So that's going to be a minimum because I went negative to positive. And x equals 5 is an endpoint. And this is an endpoint. And I'm looking for my absolutes. So what I want to do is I want to find out what the heck is g of negative 2 going to equal. And g of negative 2 is going to equal the integral from negative 2 to negative 2 of f of t dt, which is 0. And I also want to know what the heck is g of 1/2. Or no, I don't want 1/2, I want negative 1. We want maximums. So this is going to be g of negative 1. Well, that's my integral from negative 2 to negative 1 of f of t dt, which actually equals, where did I say we're going? Negative 2 to negative 1. So that's going to be a positive half, right? Right there? And that's going to equal 1/2. And I also need to know my other endpoint. I need to know what g of 5 is going to be. Well, that's my integral from -2 to 5. And I found that back in the previous section, didn't I? We found that value back here in part A. That was 9 minus 9 pi over 4. No, it was, yeah. No, it wasn't. Was it? Yeah, it was. No, it wasn't. It was 11 minus 9 pi over 4, right? So then I'm going to come back here, because I already found that before, of f of t dt equals 11 minus 9 pi over 4. Which one is your largest value? Therefore, absolute max at, and I'm going to call it 5, 11 minus 9 pi over 4, which the max value equals 11 minus 9 pi over 4. They are not going to make you give that decimal because this is non-calculator. They're not going to waste your time with those monotonous calculations. And hopefully you know pi is 3.14159, right? And if you took that times 2 1/4, it's obviously way smaller than 11, so it's going to definitely be bigger than 1/2. That little bugger is worth 3. 1 point is coming from identifying the graph you're looking at. See, don't make any assumptions. You write everything down. Identifying this as a candidate for a maximum because it was a maximum. And your final answer is g of 5 is 11 minus 9 pi over 4 for your 3 points. The last one is worth 1 point. Find the limit as x approaches 1 of that mess. Okay? Well, if I did this, remember you do limits right away, you plug them in, right? So this is going to be 10 minus 3. What the heck is f prime of 1 over f of 1 minus the arctangent of 1. What's f prime of 1? Well, f prime of 1, okay, this is the graph of f, so f prime of 1 is the slope of that line, which is going to be 2. So this is going to equal 10 minus 3 times 2 over f of 1 is 1 minus the arctangent of 1, unit circle stuff, pi over 4. That is going to give me, what is that going to give me? 10 minus 6 or 4 over what I always did. They said this, you could leave the answer like this. They accept that answer. When I did mine answer, I looked at it as 4 over 4 minus pi over 4. I multiplied by my reciprocal, and I saw it as 16 over 4 minus pi. But they'll take either one of those answers. Either one's just fine for your last one. Okay? That one wasn't too very bad. And we move on to number 4. And then remember, you got about 15 minutes per problem. So we have a cylindrical barrel with diameter 2. If the diameter is 2, my radius equals 1. Contains collected rainwater as shown in the figure above. The water drains out through a valve not shown at the bottom of the barrel, so it's leaking. The rate of change of the height of the water in the barrel with respect to times t is modeled by that ugly function where h is measured in feet and t is measured in seconds. Volume of a cylinder, they're going to give you 99% of your geometric formulas. Find the rate of change of volume in the water in the barrel with respect to time when the height of the water is 4. So this says, find dV dt when h equals 4. Right? Now, if I took the derivative of this guy right here, okay, notice my volume is going to equal pi r squared times h. That's a product rule if you have to differentiate that. However, if you come back up at your diagram, and as that water level is falling in that cylinder, notice your radius is constant. Your radius never changes. So that means we can come down here, and because we know our radius is 1, the radius never changes, the height changes. So we're going to come down here, and we're going to say, hey, we can find the volume of this thing, and it's just pi times h. That's how we find the volume of that cylinder of rainwater anytime we want it, because our radius is constant. So, because we need to find dV dt, we're going to come back, we're going to take the derivative of that guy with respect to t, which means dV dt equals pi times dH dt. Uh-oh. So what does dV dt equal? Well, dV dt equals pi times, well, what in the heck is dH dt? Well, dH dt is negative 1 over 10 times the square root of h. And if h is 4, this is going to equal negative 2 over 10, isn't it? dH dt will be negative 2 over 10 at that point, which is times negative 2 over 10. So dV dt will equal negative pi over 5. Ooh. Right? That's a 0. Oh. It's going to equal negative pi over 5. What? Indicate units of measure. Change in volume with respect to time. What is it? Feet cubed. Feet cubed. Is it minutes? Seconds. Feet cubed per second. Okay? They're always going to give you enough just to get at it. That is worth 2 points. 1 point, getting to there. 1 point for your answer. B, that same cylinder, okay? When the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Explain your reasoning. How do I find out if the rate of change of something is increasing or decreasing? How do I find out if something is increasing or decreasing? You find its derivative. So we got to come back here. We got to find, here's our dH dt. It's negative 1/10 h to the 1/2 power. We need to find the derivative of this thing, because we're finding, is the rate of change increasing or decreasing? So now we got to take the second derivative. So that's going to be d squared h over dt squared equals negative 1/10 times 1/2 h to the negative 1/2 chain rule times dH dt, because we're differentiating with respect to time. There's a chain rule in there. So this is going to give me negative 1 over 20 times the square root of h in the denominator times, what the heck is dh dt? Well, dh dt is negative 1 over 10 times the square root of h. This is what d squared d squared h. Right? This is what d squared h over dt squared is. And we're going to simplify that. Hopefully you see, well, that was kind of nice. My h is reduced right out. And what's negative 1 over 20 times negative 1 over 10? That is going to give me 1 over 200. And is it increasing or decreasing? Therefore, increasing because d squared h over dt squared is greater than 0 at t equals 3. It's always increasing, isn't it? And that is worth 3 points.
How do you know that it's at t equals 3 if you never really plug in 3? Like calculation. Just because that's what it says.
It's not t equals 3, thank you. It's h equals 3. It's specifically when the height is 3, not the time.
How do you know, again, it's like the height, you never really plug it in?
Because when the height of the water is 3 feet, the second derivative is changing constant, so it's changing at that rate all the time.
Oh.
And there's no one there's nowhere I have to plug it in.
Okay.
Huh?
If there was an age left,
Right. Correct. Correct. Yep. And that one, like I said, that one was worth 3 points. You get 1 to show you're taking the derivative of this thing with respect to time, which we did. You're getting a point for your second derivative, which is really here, and you're getting a point for your conclusion. And then we move on to C. At time t equals 0, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. This is the big point value for this problem. This is going to chew most of your points up right here. So they're saying, come back here, time t, the height of the water is 5 feet. Use separation of variables to find h in terms of t. I know dh, dt equals negative 1/10 square root h. If you don't use that, you just slit your own throat. Just saying. And I'll tell you in the grading rubric. You have to separate your variables. It was easy. I did it in my head. Then show you separated your variables. Show you're going to have the square root of, and actually I like to see this different. I like to see this as h to the 1/2 dh equals negative 1/10 dt. Yep. Curry just better quit trying to do mental math. He's really botching this business here. So we got 1 over the square root of h dh. Whoa. Then we're going to integrate that once your variables are separated. And because I am a very simpleton and I've botched this, it's h to the negative 1/2 dh equals the integral of negative 1/10 dt. When I integrate that, I get h. I'm going to add a power. I need to offset it with a constant of 2. Is going to equal negative 1/10 t plus c. Please don't forget your constant of integration. Then they come back and they tell us the height of the water is 5 feet at 0 seconds. So t equals 0, h equals 5. That's what we're going to use to find our c. So I say 2 square root of 5 equals 0 plus c. So c has to equal 2 square root 5. Which means I chop that off. I have 2h. See, I'm still going to tweak things a little bit. Now I'm going to go green on this because this is going to be 2 square root of h equals negative 1/10 t plus 2 root 5. I need to solve the equation for h. H needs to be a function of t. So I'm going to divide everything by 2. And I get the square root of h equals negative 1 over 20 t plus the square root of 5. I am going to square both sides, which means h of t equals negative 1 over 20 t plus the square root of 5 quantity squared. Then I get to the end. 4 points. Let me read the grading rubric. 1, separation of variables. 1 for antiderivative. 1 for constant of integration and it uses initial condition. And then 1 for your h of t in the end. Then below, note, 0 out of 4 if no separation of variables. If you do not show your variables separated, and you come down here and you get h of t, you get 0 for it. You get nothing. And note a max of 2 out of 4 if you don't show your constant of integration. They slam you on your notation. Okay? So make sure you show all your notation. That chewed up almost half of the problem now. And it really wasn't very difficult, was it? Wasn't too bad. Then we move on to number 5. Oh, we are so good at these now. This is an ugly one, though. Let R be the region enclosed by the graphs g of x and h of x, and the y-axis and the vertical line, x equals 2. Well, let me find the hard one. X equals 2. There it is. All you have to do is figure out which one it is. You can figure out what your y-intercept is if you want. I love my trig functions, so I'm thinking this is a vertical shift down 2 where my cosine would typically start here. And I started an amplitude of 3, which is 1, 2, 3. Therefore, I know this bottom, that's my g of x function, which means my top is my h of x function, right? And all they want is the area. And they're going to make you integrate it, too. Well, the integral, because my rectangles are vertical and I can capture top and bottom, I'm going to be in terms of x. So I'm going to integrate from 0 to 2 of, what's my top curve? My top curve is h of x, which is 6 minus 2 times x minus 1 quantity squared, minus my bottom one, which happens to be my negative 2 plus 3 cosine pi over 2x dx. Thank you very little. Now, from here, personal preference, I would take my integral from 0 to 2, and I'd say it's 6 minus 2, x minus 1 squared, plus 2 minus 3 cosine pi over 2x dx, so that I can put my 6 and my 2 together, And it's a little bit less to integrate, it's a little bit less to evaluate. So then I would say my integral is from 0 to 2. I put these like terms together and say, I got 8 minus 2, x minus 1, quantity squared, minus 3, cosine pi over 2x dx. I would spend that little bit of time before I integrate. Yes, ma'am?
I'm just confused about, like, why you're not subtracting by, like, -5 because it's also, like, it's the top curve minus the bottom curve.
Mm-hmm.
They start at -5 instead of 0, so there's no good use that.
What do you mean they start at -5?
Or, like, the bottom of it is -5.
You mean down here?
Yes.
But because this function, this top curve, what's happening is every rectangle is changing. So the top and the bottom of every rectangle is changing. That's why it's a function height minus a function height times a little bit of thickness in my dx to find the area of that rectangle. Then the next one comes to my function height minus my function height to get the height times a wee bit of thickness in there. Does that make sense? That's why I call it top curve minus bottom curve. That gives you the overall height of that rectangle. And it's not precisely each one because there's an infinite number of y values between here to here. And that's why we let the function pick them up from 0 to 2.
I get that.
Okay. And then, now I'll integrate. So I'm going to say my antiderivative of 8, that's 8x. You could have expanded that out, but you don't have to, because notice, even if I have to differentiate with the chain rule, if I raise this power 1, and I offset it with the 3 and leave the 2 in the top, if you take the derivative of that quantity, the inside term is a chain rule of 1. You take the derivative of this, the 3 comes down, it cancels the 3, I'm left with 2 times quantity x minus 1. So my derivative works. Minus 3, the antiderivative of cosine, that would be sine times pi over 2x. I have a constant, another chain rule. So if you took the derivative of this, there's going to be a pi over 2 in front of the sign yet, right? So what I'm going to do is I'm going to offset that with minus, I'm going to say 3 times a 2 over pi. Because I'm going to get a chain rule of pi over 2 that's going to come out. I'm going to offset and get rid of that constant with a 2 over pi. Or you let u equal pi over 2x, and you do a substitution on it and change it back. Is everybody with me? So my antiderivative is really 8x minus 2/3 x minus 1 cubed minus 6 over pi sine pi over 2x evaluated from 0 to 2. Which gives me my top minus my bottom. I'm going to put my 2 in there. 8 times 2 is 16 minus 2/3 times. If I put a 2 in here, 2 minus 1 is 1 cubed. So that's a 2/3. Put my 2 in here. What's the sign of pi? 0. Don't care, so this is minus 0. Then I put my 0 in here, I get a 0. Minus, if I put a 0 in here, I have my 2/3 times negative 1 cubed is negative 1. And if I put the 0 in here, the sign of 0 is 0, so I get a minus 0 yet. This is going to give me 16 minus 2/3. These are going to be positive. I'm going to distribute that, so it's still going to be minus another 2/3, right? Which, my simple mind is 16 minus 1 1/3, right? Which is going to give me, if I take the 1 away, I'm to 15. Now I got to take a third away. I'm going to be at 14 2/3 will be my area. And if you went through with common denominators, your answer is actually going to be 14 times 3. Well, that's 12. That's 42. It's going to be 44/3 if you got common denominators and reduced. I like the whole numbers and mixed numbers to subtract. And that right there is 4 out of the 9 points for this problem. All broke out in different sections. Okay? So know your antiderivatives. Let R be the region enclosed by the graph G of x and H of x still. Region R is the base of a solid. Because it's the base of a solid, remember we're going to be integrating from A to B of my area function times x, and each cross-section is perpendicular to the x-axis. That's why I did a dx. And wasn't that mighty kind of them? They gave you the area function. So all I need to do is I need to integrate from 0 to 2 of my area function dx. They're not even making you find the area function on here. They said, here it is. So I integrate that. The antiderivative of that, that's ln absolute value x plus 3. And we're going to evaluate from 0 to 2, which is going to give me the ln of 5 minus the ln of 3. You could leave your answer like that, or you could use properties of logs and say, hey, that's the ln of the top first one over the second one. Those are both equivalent answers. And that would only worth 2 points. One for the integral, one for the answer. Then we come down to number 5 here. And now, oh, thank you. Right, but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 6. So look in here in your mind, say, we are going to take this little rotation right here. We're going to rotate that. And if I drew a rectangle perpendicular to my axis of rotation, notice there's going to be a hole in some spots. Because there's going to be a hole in some spots, we're going to be doing a washer, which a washer is pi times big R squared minus little r squared. And my big R goes from my axis of rotation to my outermost. This bottom one here, remember this is our g of x function. So big R, we're taking the integral, we're perpendicular to x-axis, so we're going 0 to 2. And we're going to have big R, I might need more room than that. So I'm just setting up my template, big R squared minus little r squared dx, where big R starts at 6, top minus bottom minus g of x. My little r starts at 6, and it goes to the top function, so my little r is going to be 6 minus h of x. So all I do is I translate those down here. 6 minus g of x. Feel free to write that whole ugly mess in there if you want. I wouldn't. I'd use my function notation. And then this is 6 minus h of x dx. Write, but do not evaluate. Kruger would have just lost the point because he forgot his pi.
So is the top and bottom function like essentially flipped because when you rotate it, the bottom function ends up being on the outside now, like the shape?
It does, but remember, when you're defining your radii, you're going from your axis of rotation to your originally drawn figure for your top and bottom. But it kind of does flip-flop over.
If you think about it, like when it flips, then that the outside of it
On the top, yeah. Yep.
Okay.
Yep. But I think if we flip-flop that, we're going to get a negative area. Like if we did a g of x minus 6 squared minus that, I think we're going to get a negative
I just
area.
because like before it was h of x minus g of x, and now it's g of x minus h of x. That's
Right.
something I like.
Yep. Gotcha. Okay. So, of these 3 points, one for limits and constant, I would have lost that because I didn't have my pi on there. Got to have your pi. Form of integrand and your integrand. What do you got, Kayla? Okay. Now you got full line view.
Yeah, the whole other time I was like,
Okay. Here's an easy one. Find h prime of 2. Here's our last one. Functions f, g, and h are twice differentiable functions. With g of 2 equals h of 2 equals 4, the line y equals 4 plus 2/3 x minus 2 is tangent to both g and h at x equals 2. What is the derivative of h at 2? Well, it has to be equal to the slope of that tangent line because that's the point of tangency for the function. Those 2/3. Done deal, 1 point. Then, let a be a function given by a of x equals 3x to the third times h of x. Write an expression for a prime of x. This is a gimme, man. Can't get these points. But, you know what they're testing you? Do they identify we have a product? A prime of x equals the derivative of the first term times the second term plus the derivative of the second term times the first term. Here's my derivative. Then we want a prime of 2. Well, a prime of 2, well, when I plug a 2 in here, that's going to give me 4 times 9. That gives me 36 times h of 2. H of 2 is 4. Plus h prime of 2.
2/3.
2/3 times, put a 2 in here, that'd be 8 times 3 is 24, right? So 36 times 4, that's 24, that's 144, plus 1, 8, 16, 144 plus 16, that means a prime of 2 equals $1.60. Now we get to the hard one. These last two made me think for a little bit, I'll be honest. They made me think. Is everybody good so far? I'm going to do the best I can to explain these to you. I think I can do it. And if you looked at the grading rubric, mine doesn't look anything like the grading rubric, the way my brain processed it. So the function h satisfies h of x equals that for x unequal to 2. It is known, it is known that the limit of h equals, as x approaches 2, can be evaluated by Signor L'Hopital. Ah, big information as far as I'm concerned. Use the limit as x approaches to of h of x to find, we need f of 2 and we need f prime of 2 using that limit. Before I go, did anybody get this problem? Here's my thought process on it. Maybe it helps. I don't know. I said, well, to use L'Hopital's rule, then we know that the limit as x approaches 2 of h of x has to, the limit h of x has to equal 0 over 0. Right? Because I know I'm plugging a 2 in here, so I know the numerator is 0, so I have to have 0 in the denominator. It's not infinity over infinity. It's 0 over 0. Therefore, f of x has to equal 1. Because I got to take 1 minus 1 cubed to get 0 in the bottom. That's how I found my f of 2. Excuse me. Because when I'm taking the limit as x approaches 2 of 2 squared minus 4 over 1 minus f of 2 cubed, this has to equal 0 over 0. So f of 2 has to be 1. There ain't nothing else it can be. Right? Then, I went on and said, also, if because we want f of 2, if the limit also, if f and g, f and g, right? But I only need f. So if f is continuous, focus Kruger. If f is differentiable, then it is also continuous. And if it's differentiable and continuous, therefore, the limit as x approaches 2 of f of x equals f of 2, which equals 4. Right? And I'm using that, boy, my twisting my words. I'm using that for my h of x. I'm using this all for my h of x. Come on, Kruger. H. If h is differentiable, it's also, so h, so that means h of 2 is 4. They gave me that up here too. So because it's differentiable, okay, the limit has to exist. And they told me h of 2 is the same as the limit. So, if I took the limit as x approaches 2, so using L'Hopital's rule, the limit as x approaches 2 of this, when I take the derivative of the top, I get 2x over the derivative of the bottom is going to be negative 3 f of x squared times f prime of x, right? It's going to equal negative 3 f of x squared times f prime of x. And I know if I'm plugging this in, this is going to equal 4 over negative 3. I know f of 2 is 4, right? Oh, yeah. Yeah, see him. There's 1 squared times f prime of 2. At least somebody's tracking me. My mind's scrambling. F prime of 2. Hey, we already know what this limit equals, don't we? Because we know what the limit is h of x, it's going to be 4. We know this equals 4. So, I can say this is 4 over negative 3 f prime of 2. That's 4. Which means 4 equals negative 12 f prime of 2. Which means f prime of 2 has to equal negative 1/3. That was a hard one, in my opinion. That was a hard one. The last one's a hard one, too. But the last one is going to be using this exact same concept right here. Okay? And it's a lot of writing. And remember, this video is going to be posted if you don't get all your notes. Actually, I can print it as a PDF and push it out on Flare too. The whole notebook. So now the last one, it's known g of x is less than h of x for all x between 1 and 3. Let k be a function that is between, always between g and h, between 1 and 3. Is k continuous at x equals 2? Justify your answer. Well, they still gave me all this business. Okay? Well, because g of x and h of x are differentiable, they are also continuous. And you have to remember what the definition of being continuous is. To be continuous, the limit of the function at a value of x equals the functional value at the same x value. Okay? So because, therefore, the limit as x approaches 2 of g of x, that equals g of 2, which is 4. These two equal because it's continuous and differentiable. And the limit as x approaches 2 of h of x, that equals h of 2, which is 4. Okay? Therefore, I'm going to use my dots. You probably don't remember this one. Therefore, by the sandwich theorem, if g of x is also always less than k of x, which is less than or equal to h of x, on 1 to 3, and the limit of g of x and the limit as x approaches 2 of g of x equals 4, that's going to be less than or equal to the limit as x approaches 2 of k of x, which is less than or equal to the limit as x approaches 2 of h of x, which is 4. I know for the limit of k of x is 4. And if g of 2 is always less than or equal to k of 2 less than or equal to h of 2, 4 is less than or equal to k of 2, which has to be less than or equal to 4. So the limit as x goes to 2 of k of x equals k of 2 equals 4. Therefore, yes, it's continuous.
Would all of that be necessary to get to a point?
I don't know. I can guarantee they're looking for this 100% in there. They're looking for identifying with the sandwich theorem in there. And in order to be continuous, you're going to have to show that at the same time, which means you need to show that in your sandwich theorems too.
Would they want you to say sandwich theorem or squeeze theorem?
Doesn't matter. It's identified either way. Squeeze theorem is